Ahoy, ahoy, everyone. Welcome back. We are going to start Unit 4, which deals with series, sequence, exponentials, and logs. Okay, these will be somewhat shorter and more condensed. Um, for the sake of time, I would like to get through them somewhat quicker, meaning not as many lessons in a unit. And let's start to move forward, okay? Today, lesson 1, the arithmetic and geometric sequences, all right? So let's dive right in and just define what a sequence is. Okay, a sequence is a list of numbers that follow a pattern. A list of numbers that follow a pattern. Of course, we have two types of sequences that we're going to look at: arithmetic, okay, and geometric, all right? Please note that arithmetic, oh, I love me some highlighters. They have something that is called a common difference. Okay. And what does that mean? Well, let's come up with a sequence here. How about we have 5, 8, 11, 14, and so forth. Now, it does not take a rocket scientist to figure out that in order to get from one term to the next term, all I'm really doing is adding 3, correct? And so forth. So guess what? My common difference, which they use the variable d, is a positive 3. Okay, that's what this means. Okay, so let's now go over highlighters. Geometric series. Okay, they have something called a common ratio. All right, common ratio. And let me give you an example of a sequence that is geometric: 10, 20, 40, 80, and so forth. Okay. Now, when I look at this, I should know right off the bat, I'm not just adding a number that's constant to get to the next term here. I can't, because it's increasing, or it can decrease sometimes at a larger and larger rate. But if I look at this, I can say, I get to 20 by multiplying that times 2. I get from 20 to 40 by multiplying it times 2, and so forth. So if we had to guess what our next one would be, we should know that would double and get to 160. Same thing with 14 here. If I had to guess what the next term would be, I would just add 3 again, and it would be 17. So if we know the pattern, okay, we know the common difference for arithmetic, we can get to the next term. If I know the common ratio, which they call R, that ratio is I'm multiplying it by 2. Okay, I can continue that list. All right. Now, I just want to point something out. If I have a sequence, if I have a list of numbers, I can look at it and determine whether it's arithmetic, because it goes up by the same every time, or geometric. There's some sort of common factor or common ratio. All right. And they want me to come up with an explicit formula. They want me to come up with an equation to represent that sequence. I use both of these. Okay. This is what I would use for arithmetic. And this is what I would use for geometric. Now, don't freak out. They're both on the reference sheet for the final, okay? You might see one question, excuse me, about creating a formula or two on the multiple choice. And if it's short answer and they ask you to come up with an equation, well, they're both in the reference sheet. What we need to do is we need to figure out what type of series it is, and then what each one of these variables in these equations represent, okay? Well, this is like your y. This is your output. We're always going to leave that a to the n for right now, okay? It's just a general term, whatever. The first term in your sequence we call a1. That's the first term. So if I were to go back, the first term in my arithmetic sequence is 5. The first term in my geometric sequence is 10. Okay, so that's pretty obvious. This is A1. The next term will just be A2, A3, and so forth. Okay. Now, what's n? N is just the term position. We are going to leave that variable as n. That will always stay n. See, here's an n here. Now, n is like x. Like if we had a function, a to the n, it would equal something like 3. And this is the variable I use, isn't it? So if I'm using my n variable, I need to have an n in there somewhere. That n will always be n. We will never put a number in for it when we're coming up with the equation. Our equation needs a variable, and our variable happens to be n. Okay? Notice it's always n minus 1. Notice this exponent is always n minus 1. Okay, let me some of this stuff out here. Erase a lot of these arrows. And last but not least, I should be using highlighters. I'm so insensitive. Oh, okay. First term. First term. Okay. I'm always using an n, and it's always n minus 1. Okay. I'm always using an n, and it's n minus 1. All right. So the last thing I need, I multiply when it's arithmetic times my common difference. Okay. My common difference, you can tell just by looking at it. Okay. And here, oh, I can't highlight that in green. It would cover it right up, would it? Oh, look at that. Woo. Okay. That's my common ratio if it's geometric. And of course, yep, my common ratio, we should be able to tell just by looking at it. Okay. So now that we've kind of explained what all these things are, it's always nicer, and I always say this, to actually start using these. Okay. And then you get more and more comfortable with them. So let's do just that. I've retyped, for the sake of having these on the board, not going back and forth to my slides, both of my formulas for getting the equation for an arithmetic and a geometric sequence. So let's look at number 1. 4, 8, 12, 16. All right? Well, I hope you know that's arithmetic, because all I'm doing is adding 4 to each term to get to the next term, okay? So right now, my very first term happens to be 4, and my common difference also happens to be 4. It doesn't always happen that they're the same. That's not a rule. Don't make your common difference always the same thing as the first term. That happens to be what we have here, okay? And again, for visual people, first term, okay? Common difference. There you go. So this is what we're going to do. My common difference goes there. My first term goes here. And that's really the only two things I need. So when I write this, I say a sub n equals my first term, just 4, plus n minus 1 times my common difference, which is 4. That's it. That's done. That's it. Now, some people will ask, do I have to distribute that? You don't have to. But please keep in mind, short answer, this is fine. If it was multiple choice, they might distribute this. They might distribute the 4. They might make it 4 plus 4n minus 4. And if I simplify that, a positive 4 and a negative 4 cancel. So ultimately, this is okay as well. That's simplified, okay? If they don't ask you to simplify it, what I wrote in black is fine. If it's multiple choice, you might come up with what's in black, but it might be listed as what's in green. Just know that if you distribute and combine like terms, it could look slightly different. They both give you the same answers, ultimately, if I plug in values for n, okay? Now, let's look at number 2. Number 2 here is a geometric series. How do I know that? Because in order to get from 8 to 16, I multiply times 2. 16 to 32, I multiply times 2. 32 to 64, I multiply by 2. Okay? So, my first term is 8. A sub 1 equals 8. My common ratio is a positive 2. So let's do this again. First term, 8. Bang, right there. Common ratio, 2, bang, right there. And that's all we need. It's actually a little bit easier to write the equation of the other one was easy as well, but these are all easy. So A is 8 times my R, which is 2, and I literally leave this n minus 1 as my exponent. Done. Now, I can't simplify that at all. That is good to go. I love it. I love it. I love it. And that's really all you do. Now, I'm saying this for the rare person who might have difficulty identifying a common ratio. This is obvious that it's 2. Okay, my common ratio is 2. All right, I'm going to go ahead and erase this. If you are struggling finding out your R value, you can always take the second term and divide it by the first. So you can take one term and divide it by the term in front of it. So if 8 is A1, 16 would be A2, 32 would be A3, 64 would be A4, and so forth. If I take A2, which is 16, and divide it by A1, which is 8, 16 divided by 8 is 2. Let's try that with another 2. Let's try with the last 2 here. Let's take A4 and divide it by the previous term, A3. A4 is 64, A3 is 32, and that is 2. This will always be your common ratio, okay? I don't think you need to do that in this case right here, but sometimes you get a case, maybe you get a fraction as a common ratio. Oh, I said it. I said the F word. I said the F word, fraction. Sometimes you get a fraction. Sometimes a negative number. You want to confirm it? Just take one term and divide it by the previous term. I could take one term, I could have taken 32 and divided it by 16. It still works. All right, we have 6 problems here. Yeah, if you just don't see them on the board, there's the last 2. Identify if the following is arithmetic or geometric. State the common difference or ratio. Then write an explicit formula for it. Okay, I will do the first one. If you want, you can pause this. I think based on the first 2 examples I gave you, you should be able to do all 6 of these. If not, I will do the first one slowly, and then I'm going to rip through the rest of these rather quickly. You've got a pause button and a rewind or whatever. Okay? First one, 3 to 7. So I add 4, okay? I add 4. So what about 7 to 11? Guess what? I still add 4. And then 11 to 15, I still add 4. Okay? So my common difference is 4. My first term is 3. Okay, so I'm going to say, I'm going to rewrite this. It's a to the 1 plus n minus 1 times my common difference. Well, first of all, I'm going to say arithmetic. I'm going to answer the question. It is arithmetic. My common difference is 4. They asked me to decide, okay, is it arithmetic or geometric? And I did. They want to state the common difference or ratio, and I did. Now I'm coming out with a formula, okay? So a to the n equals my first term plus n minus 1 times my common difference. Now, if I want this simplified, which maybe you should get in the habit of doing, that would be 3 plus, okay, I distribute my 4. 4n minus 4, which ultimately equals, okay, 4n, and I've got 3 minus 4 minus 1. So what I have here in red is a simplified version of my equation. What I have in green is the equation. Okay, it's the explicit formula or equation. All right, so now I'm going to go a little bit quicker through these, and let's go. Okay, to get from 30 to 25, 25 to 20, and 20 to 15, that's arithmetic, because I know my common difference is negative 5. I'm subtracting 5. And I could do that, that's fine. A1 is 30. So my equation is my first term plus n minus 1 times my common difference. Big deal if it's negative 5. You just multiply by a negative 5. All right, that is good. If I wanted to combine these, and again, you guys should, I get 30 plus negative 5n, okay, plus 5, because a negative times a negative, which means my a to the n could equal negative 5n. 30 plus 5 is plus 35. All right, very good, very good, very good. Next one. Oh, 3 to 6 to 12. I'm really doubling these. So this is geometric, and my common ratio is 2 because I'm doubling. I'm multiplying by 2. My first term is 3. So a to the n equals my first term times my ratio, my common ratio, raised to the n minus 1. And these we don't simplify. That is 3 to the 2, excuse me, 3 times 2 to the n minus 1. Those are easier because there's no simplification, okay? And the common, the arithmetic sequence to get an equation is not difficult. This is literally, geometric is less writing, okay? Woohoo! The fourth one, letter D. Okay, negative 5 to negative 2 to 1. Well, 1 to 4 would mean I add 3. And guess what? Negative 2 to 1 is still add 3. Negative 5 to negative 2 is still add 3. So this is arithmetic. My common difference is a positive 3. Okay? My first term is negative 5. So a to the n equals my first term plus n minus 1 times my common difference, which is 3. Absolutely acceptable. I want you guys to simplify, which means this becomes 3n minus 3. So negative 5 plus 3n minus 3. So a to the n equals 3n. I have minus 5 minus 3. Let's call it minus 8. That's a simplified version. It's okay, not bad. I think you guys are getting somewhat decent at this. Charty char. Now, E. Okay, in order to get from 64 to 16, if I were to subtract, that's not the same value I subtracted from 16 to 4 or from 4 to 1. Okay, so it's not arithmetic. This is definitely geometric. Now, most people do this. I divide by 4. I divide by 4. Please, a common ratio should be what you multiply by. So, if I take 8 and I divide it by 4, I'm just giving you an example here, that equals 2. That's the same thing as 8 times 1/4. So whatever you divide, you put underneath 1. So I'm not really dividing by 4. I mean, I am. But in terms of multiplication, I'm multiplying by a 4th. I'm multiplying by a 4th. I'm multiplying by a 4th. Okay? So again, I want my common ratio to be multiplication, not division. Okay? So if it's geometric, my ratio is 1/4. So my first term is 64. So my equation should be my first term times my common ratio to the n minus 1. Okay, please understand that. If I was dividing by 11, that means I'm multiplying by 1/11. Okay, if I'm dividing by 6, that means I am multiplying by 1/6. Okay, so remember, we want what we're multiplying by, not what we're dividing by. That's my common ratio should be. Okay, last, but certainly not least, letter F. I know to get from 2 to 4, and from 4 to 8, and 8 to 16, I multiply by 2. However, notice I'm going from negative to positive. So how do I make negative 2 into positive 4? I multiply by a negative 2. Let's see if that works. I get from positive 4 to negative 8. Oh, I multiply by negative 2. And get from negative 8 to positive 16. Okay, so anytime I have to flip the sign, see how the sign changes from negative to positive to negative. That means when I multiply something, I'm multiply by a negative value. Multiplying by a negative value flips or switches my sign. All right? This is definitely geometric. My r is negative 2. Okay, let's come up with an equation. My first term, easy. It's negative 2. So a to the n equals my first term times my common ratio raised to the n minus 1. My first term happens to be the same thing as my r, so you're good to go there. Doesn't always happen like that. Sometimes it does. A lot of the times it does not. 6 problems. There you go. Oh, man, it was going so good. It was going so good. Life was so easy. And then they threw a word problem at us. Well, so is life. Just when you think you're on cruise control, you got to slam on your brakes because some idiot in front of you is tailgating the guy in front of him. All right. How sexist of me. How sexist of me to assume that it was a man that was tailgating. Maybe it's a woman. Who knows? Anyways, the person would be tailgating. Anyway, let's just do the problem. Example, whatever this number example is. Row 1 in an arena contains 14 seats. Row 2 in the arena contains 17 seats. Row 3 contains 20 seats. If this pattern continues, how many seats will there be in row 13? Well, let me see. When my n is 1, my value for A1 is 14. Okay, for row 2, the output A2 is 17. For row 3, okay, I'm just following this. In row 1, it's 14. In row 2, it's 17, and so forth. In row 3, my A3, or my output, would be 20. All right? This would be A to the N. Okay, it's like X and Y, if you will. All right? Kind of like X and Y. Now, so forth. I can do this until I get to 13, which is A13, with a calculator. Okay? Because it looks to me like this is an arithmetic series. It looks like all I got to do is add 3 to get to the next one. So in my calculator, I can add 3, 12, or 13 times. Or to get to that 13th term, you could do that. Okay, but if they tell you to show your work, I guess you would have to show all those numbers adding. And you can, but we know how to come up with a formula to find any term. That's what we've been doing. Okay? This is an arithmetic sequence. My common difference is 3. My first term, a sub 1, is 14. So, just as a reminder, in order to come out with an equation, I take my first term, I add n minus 1 times the common difference. So, in order to find my equation, I take my first term, I add n minus 1 and multiply that times the common difference. Now, here you go. They want to know A13. So, guess what I do? If they want to know A13, that means my n is 13. That means I need to put 13 in for my n. Okay, so it's 14 plus 12 times 3. 12 times 3 is 36 plus 14. And if I add those, $50 seats in row 13. 50 seats in row 13. Let me recap this one more time. I think coming up with the equation is easy. It's right here. Okay? But they want to know what A13 is. So for my n, I need to put in a 13. That means wherever there's an n, I put in a 13 and I just simplify. That is it. Okay? That is it. And we come up with 50. When Johnny was a year old, okay, his grandparents gave him $50. For each birthday, they increased their previous gift by $50. So when he was 1 year old, he got $50. When he was 2 years old, they increased that by 50 to 100. When he was 3 years old, they increased that by 50 to 150. So how much would they give Johnny on his 18th birthday? So if my n's, it's 1, 2, 3, and so forth. My a to the n's, on his first birthday, they had 50. They increased it by 50 bucks. They took the previous amount and increased it by 50 bucks each time. So I'm adding 50 to 100. I'm adding 50 to 150, okay, and so forth. So this is obviously arithmetic. My common difference is 50, okay? My first term, a sub 1, is 50. A sub 2 is 100. A sub 3 is 150, and so forth. On his 18th birthday, that's when my n is 18. They want to figure out what's a of 18. Let's come up with an equation. My equation equals my first term plus n minus 1 times my common difference. All right? Well, let's do this. We have 50. We want to find a of 18 plus 18 minus 1 times 50. And for the sake of time, if you put that in a calculator, you should end up with $900. Bam. So on his 18th birthday, they're going to give the kid $900. Huh, look at that. Can't even get an S10. Cheap grandparents living on a budget because they're retired and they're concerned about themselves. That's what's going to happen one day. You better prepare financially. You better prepare. Anyways, $900. That's what my man Johnny should get alone on his 18th birthday. On his 17th birthday, it was $50 less. He got $850. On his 16th birthday, I shrunk that by $50, and he got $800. So his grandparents over the years actually gave him quite a bit of money. If Johnny was smart and not stupid and he saved it, he would have a nice amount of money, and we'll eventually get there where we add up all these things, but not right now. Okay, you're going to see this recursive sequences thing. Okay, what is a recursive sequence? Well, it is a sequence. It helps if I put an E on sequence with a repetitive rule. I hate to use the word, well, no, repetitive is good because it says recursive. Repetitive rule, okay? Listen, this is important. They have to give you a term, and it's typically the first term. The first term. It doesn't have to be the first term, but on the final, you'll see why that is important, okay? They have to give you the first term, okay? I cannot, okay, here we go. Before I even get excited and on this whole thing here, the basis behind this is you can only find your next term. Whatever term they give you, you can only find your next term. With what we've been doing, okay, once I come up with an explicit equation, I can find any term. They wanted A18. I didn't need to know A17 to find A18. Explicit. Recursive, I can only find the next term. I can only find A18 if I have A17. And they have to give you that term, A17. On the final, for multiple choice, they have to give you a term, and it's typically the first term on multiple choice. I have some sample problems that we can look at in a minute. Okay? So, find the first 4 terms of the sequence. A to 1 is 2. And the recursive definition or equation is a to the n equals a to the n minus 1 plus 6. Okay, this is this an example of arithmetic or geometric? Explain. All right, well, that's fine. All right, here we go. Boom. So I'm going to take A1. They give that to me. That's 2. I need to find A2. I need to find A3. I need to find A4. These are the first 4 terms. They give me this. This A minus 1, that means your previous term. Okay? So in order to find A2, I need to take my previous term A1 and add 6 to it. 2, that's what A1 is, plus 6 is 8. In order to find A3, I need to take my previous term, A2, and add 6 to it. A2 is 8. 8 plus 6 is 14. In order to find A4, I need to take my previous term, A3, and add 6 to it. A3 was 14. 14 plus 6 is 20. There are your first 4 terms. 2, 8, 14, 20. That is arithmetic because it is a common difference of 6. I'm just adding 6 to each one of those previous terms. Meaning, plus 6, plus 6, plus 6. Okay? Now, there is an easier way. There are equations for recursive, meaning, I'm going to write these. I probably should have written them under here. If I want recursive for arithmetic, I take the previous term and I just add what my common difference is to it. How do I get from one term to the next? I add my difference. Okay, they got to give you A1 has to be given, right? Or the previous term, whatever. So for geometric, and this is really kind of common sense, I take my previous term. Oh man, I am such a speed demon here. The previous term would be I minus 1 from there. I take my previous term, and all I do is I multiply that times my common ratio. Like if I'm doubling everything, I take my previous term and I just double it to get to the next term. Of course, they have to give you a term. I always say it's A sub 1 the first term, because on the final, that's a big thing. If they don't give you a term, the first term or whatever, it is not recursive. Okay? If they don't give it, is explicit. They have to give you a term. All right, here are some common Regents questions on recursive sequences. At her job, Pat earns $25,000 the first year and receives a raise of $1,000 each year. Okay, the explicit formula for the nth term of the sequence is a to the n equals to, look, it's just the explicit formula. Here's our first term, n minus 1, here's our common difference. Which rule best represents the equivalent of a recursive formula? Number 1 and number 2 do not give you the first term. They don't give you any term. You see 3 and 4? 3 and 4 actually give you what A1 is. By definition, that has to be there to be recursive. So I know 1 and 2 cannot be recursive. It's either 3 or 4. Okay, now be careful. What's the equation? I know I add my common difference, but which term here means the previous one? The minus 1 means the previous one. If I have A of 2, let's say n is 2, what's A to the n minus 1? Well, if n is 2, A to the n minus 1 would be A1. That's the previous. Subtracting 1 gets you to the previous spot. Adding 1 would get you to the next spot. Okay? And remember, we always want to add our difference to the previous number to get our next number. Okay? So if I have 6, 7, 8, 9, obviously my common difference is 1. I'm adding 1. Okay? So how do I get 8? Do I add 1 to the next number to get 8? Or do I add 1 to the previous number? I add 1 to the previous number to get 8. You want the previous number. Here's another one. The population of Jamesburg for the years 2010 through 2013, respectively, was reported as follows. 250,000, 250,937, 251,878, and 252,822. How can this sequence be recursively modeled? Recursively, they need to give me an element. 1 and 2 do not. They just give me an equation. Here's an element, and here's an element. So it's either 3 or 4. All right. I am not adding the same amount to each number to get to the next number. It is geometric by nature. Okay? So, which one, 3 or 4, is geometric? This one, where I take my common ratio and multiply it times my previous term. This I'm just adding. Okay? If I tried 4, if I took 250 and put it there and added 937, I would get this. But then if I took 937 and added it to my second number, I would not get my next one. Okay, so it can't be 4. You could just, you can just try it out, get going, or you could know your equations. Either one, you are good to go. And last but not least, a recursive formula for the sequence 18, 9, 4.5 is what? First of all, recursive. It needs to give me an element. It gives me an element here. Good. Possibility. Does not give me an element here. Bang. Oh, it gives me an element here. Possibility. Does not give me a first element here. Bang. It's either 1 or 3. So, am I doubling each term, multiplying it by 2? Or am I multiplying each term by a half to get to the next term? How do I get from 18 to 9? Do I multiply it times 2, or do I multiply it by a half? Well, if I multiplied 18 by 2, I'd get 36. My common ratio is 1/2. The answer is 1. My common ratio is not 2. So you see, every one of these multiple choice questions that were right off finals, when they ask you about recursive, you can cancel half of the responses. So you only have to choose between 2 instead of 4. So that's a key thing to know. Recursive means they have to give you an element. And look, all 3 of these problems, they gave you G1. Now watch, this year they'll give you like G3 or something and you're going to find G4. That can happen, but they have to give you an element, okay? I will see you for Unit 4, Lesson 2. Well, that wasn't so bad. See ya.